Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to cover chapter 6. It's about data design, and in this part 1 video of chapter 6, we are going to cover on data design concept. Okay, before we start to a new chapter, which is chapter 6, system data design, as usual, I want to recap software development life cycle phases. Okay, as you can see in this diagram, you are now in phase 3, which is system design. Okay, uh, let's have a look what you have went through or doing during the first two phases. Okay, phase 1, system planning, which is the purpose of this phase is to identify the nature and scope of business opportunity and problem. In this phase, you have learned about IT projects, get started, and how system analysts evaluates a proposed project and determines its feasibility. Okay, the output from this phase is system development planning, which is the document you have submitted to me. Okay. Okay, the second phase is system analysis. Okay, the purpose of this phase is to build a logical model of the new system. And in this phase, you have learned about requirements modeling, interface modeling, and development strategy. And the output of this phase is system requirement specification. Okay, which is in this document, you should provide a logical design of your system, which cover entity relation diagram, data flow diagram, data dictionary, and process description too. This document also you should have submitted already at this stage, meaning that we have covered a logical design of your system. So now the third phase, system design, which cover physical design. So under this phase, you will learn about data design, okay, which cover in chapter 6, and user interface input and output design in chapter 7. The purpose of this phase is to create a blueprint, which is a technical drawing that will satisfy all documented requirements, which cover outputs, inputs, and processes. So the output in this phase is a system development design. So this is going to be your next task. Actually, we have covered a few topics of third phase in chapter 5, which are, if you remember, which are system design guidelines, which is the design guideline will guide you to set a design objective of the system that you are going to develop. Okay. The second topics we cover in chapter 5 is prototyping, which you learn about prototyping methods and tools used to produce an early working version of the proposed information system. And the third one is using codes during system design. Okay, here you learn about how to use a codes that can be used to simplify output, input, and data formats in order to reduce data input errors, because code data is easy to remember. Okay, I think that's all recap for the previous chapters. Please scan this QR code for the quiz. Okay, now I assume you are ready to begin the physical design of the system that will meet the specifications described in your system requirements document. So you should know that system design tasks will include data design, user interface design, and system architecture. The objective of chapter 6 basically to make you understand on the elements of data designs, which are data design concept, Dbms components, web-based database design, data design terminology, data relationship normalization, database model, data storage, and data control. In this part 1 video, I will cover only first element, okay, which is a data design concept. Okay, as I mentioned in a previous slide, data design is a physical design in system development. Okay, please remember that. So you will develop a physical plan for data organization, storage, and retrieval. It begins with a review of data concepts and terminology, then discuss file-based systems and database systems, including web-based databases. So towards the end, it concludes with a discussion of data mining, data warehousing, physical design issues, logical and physical records, data storage formats, and data controls. So before constructing an information system, a system analyst must understand basic design concepts, including data structures and the characteristic of file-oriented and database systems, including web-based database design. Okay, so don't worry, we will go details one by one. Okay, next. As I mentioned earlier in introduction slide, when we talk about data design concept, we have to think about data structures, file processing, and database system. So what is data structure? Data structure is a framework for organizing, storing, and managing data. Okay. Data structure consists of file or tables that interact with the system in various ways. It could be a file-oriented systems or database system. So a file-oriented system is also called a file processing system. Okay, each file or table contains data about people, place, things, or event. For example, one file or table might contain data about customers, and other files or table might store data about products, orders, suppliers, or employees. So depending on how the files and tables are designed, an information system is called a file-oriented system or database management system. So this diagram, for example, shows sample of data structure in job records system and employee record system. Okay. Okay, this is an overview of file processing. Actually, file processing is an older approach. Okay, some companies use file processing to handle large volumes of structured data. Although less common today, file processing can be more efficient and cost less than a DBMS in certain situations. So this diagram shows a credit card company use a file processing system to post daily sales transaction from a transaction file to customer file. Three potential problems exist in file processing environments, which is the first problem is data redundancy, which means that two or more data is stored in several places. Okay, the second one is data integrity problems. It occurs if updates are not applied in every line. meaning that changing the data in only one of the systems will cause inconsistent data and result in incorrect information in the second system. Okay, so the third one is rigid data structure. Basically, a file-oriented information system can contain various types of file, including master file, table file, transaction file, work file, security file, and history file. Okay, overview of database systems. A properly designed database system offers a solution to the problems of file processing. Okay? A database provides an overall framework to avoid first data redundancy and support. The second problem is support a real-time dynamic environment. Okay, these are two potential problems of a file processing system. Okay. This diagram shows that a sales and marketing database that support 5 separate business systems, which are sales forecasting system, inventory management system, order entry system, production planning system, and accounting system. This is just for example. Okay, now is a database management system, DBMS. Okay, DBMS is a collection of tools, features, and interfaces that enables user to add, update, manage, access, and analyze the contents of a set of data. Okay, so the main advantage of DBMS is that it offers timely, interactive, and flexible data access. Microsoft Access is example of personal DBMS. Okay, if MySQL, it is a relational database. What is the difference between DBMS and RDBMS? Basically, DBMS is a software that is used to define, create, and maintain a database that provides control access to data. Relational database management system is an advanced version of DBMS, okay, which is in RDBMS, data is stored in the form of tables which are related to each other, okay, and it can deal with large amount of data for multiple users compared to the DBMS, which is a single user. I think never mind. When you practically develop the database in 4 phases in system implementation, you will understand what is the RDBMS. So this is just additional knowledge for you. Okay. Okay, these are the advantages of database system, which are scalability, better support for client-server systems, economy of scale, flexibility, data sharing, enterprise-wide application, stronger standard, control redundancy, better security, increased programmer productivity, and data independence. Okay, scalability means that a system can be expanded. Okay. Better support for client server systems. This one you will learn about client server system in a later chapter. Economy of scale, the efficiency of high volume processing on larger computers, which is called economy of scale. Flexible data sharing is referring to you allowing more users to access more data. Okay, enterprise-wide application, it is about manage a person called data administrator. Stronger standard is the standard for data names, format, and documentation followed uniformly throughout the organizations. Okay, control redundancy is the database approach, allows control of the redundancy. Okay, better security is only legitimate users can access the database. Increase programmer productivity, which is a new database application can be developed more quickly than in a file-oriented system. Okay, data independence, which is about provides a DBA, which is a database administrator, to alter data structures without modifying information systems that use the data. Okay, database trade-off. Trade-off, I think I have mentioned about the trade-off definition in the previous video. Trade-off is something that you have to consider, okay, in terms of making decision. So for the DBMS, okay, because DBMS are powerful, they require more expensive hardware, software, and data networks capable for supporting multi-user environment. All right. DBMS also more complex than a file processing system, and procedures for security, backup, and recovery are more complicated and critical. These are the things that you have to consider for DBMS when you design your system. Okay, I think that's all about data design concepts. Okay, our next video will cover about DBMS components. Okay. In this section, we will cover about interfaces for users, database administrator, and related system. Okay, a data manipulation language, a schema, a physical data repository. In this section, also we are going to cover about data management techniques, including data warehousing, which stores data in an easily accessible form for user access, and data mining. Okay, I think that's all in this part 1 video. See you in the next video. Okay, inshallah. Assalamualaikum warahmatullahi wabarakatuh.